Dear children, now let us solve the 2 marks question of the LBA of the chapter circles. Question number 27. What is that question? In the given figure, PA and PB are the tangents to the circle with center O. If PA equals 4 cm and angle APO equals 40 degree, then find the measure of angle AOB and find the length of PB. You know that in the given figure, P is a point outside the circle which is called the external point. Tangents drawn from the external point to a circle are equal. So you can take PA is equals to PB. Then if the length of PA is equals to 4 centimeter, then the length of PB is also 4 centimeter. You got the length of PB, that is asked here. Length of PB is 4 centimeter, that you can write next. Next, what is to be find out here? Angle APO. If you consider the triangle APO or OAP, OAP is an right angle triangle. Angle OAP is equals to 90 degree. Here also angle OBP is equals to 90 degree. Triangle OAP and triangle OBP are congruent. Why they are congruent? Here if you take the two triangles, angle OAP is equals to angle OBP. Both are equals to 90 degree. That is according to theorem 10.1. Angle between the radius through the point of contact is 90 degree. So, the tangent and the radius through the point of contact are perpendicular to each other. Therefore, OA perpendicular to PA and OB perpendicular to PB. So, angle OAP and angle OBP are right angles. And OA is equals to OB. They are the radii of same circle. And OP equals OP. They are the common side. You can take the two triangles are congruent. So, you got PA is equals to PB. And also, here angle APO is equals to angle OBP. And angle AOP is equals to angle BOP. As these two are congruent triangles. Then as this is 40 degree and this is 90 degree, you will get the measurement of the angle OAP which is equals to 180 minus 90 plus 40 which is equals to 50 degree. So you write, then you write in the figure angle OAP equals angle OBP equals 90 degree. Angle OBP equals 90 degree. Reason you can write theorem 10.1. That is the angle between the tangent and the radius through the point of contact. Now you take the name of this triangle. In triangle AOP, in right angle triangle AOP, what you have to find out? First you get angle AOP. Angle AOP equals 180 minus this 90 degree angle and this 40 degree angle. 180 minus 90 degree plus 40 degree. You can use angle sum property of the triangle because 180 degree is the sum of the three angles of the triangle. You write angle sum property of triangle. Now you write angle AOP equals 180 degree minus 90 plus 40 is equals to 130 degree which is equals to 50 degree. 180 minus 130 is 50 degree. And angle AOP is equals to angle BOP. Both are equals to 90 degree because you proved that these two triangles are congruent. Triangle AOP is congruent to triangle BOP, that is proved while proving the theorem 10.2. We know that angle AOP is equals to angle BOP, both are equals to what? 50 degree. Because triangle AOP is congruent to triangle AOP is congruent to triangle BOP. So CPCT of this two triangle, that is proved. Where it is proved? In theorem 10.2. You must know it. So 50 plus 50, which is equals to 100 degree. Therefore you write angle AOB is equals to 50 degree plus 50 degree, which is equals to 100 degree. 50 plus 50 is equals to 100 degree. And also here AP is equals to BP, that is according to the theorem 10.2. You write BP equals AP. Both are equals to what? 4 centimeter. That is reason theorem 10.2. Tangents from the external point are equal in length. Theorem 10.2. Therefore you write BP is equals to how much? 4 centimeter. BP is equals to 4 centimeter. Question number 28. In the given figure, AP, AX, AY are the tangents drawn to the circle. Prove that AY is equals to AX. Here two circles are there. They are the circle with different center, and two tangents are drawn to the circle with center D, and also two tangents are drawn to the circle with center C. Here D is the center of the bigger circle and A is the external point. AY and AP are the two tangents drawn from the external point A. So they must be equal. Similarly, to the circle with center C, from the external point A, same external point, AX and AP are drawn. They are also equal. Here, to AP, AX and AY are equals. To AP, AY and AX are equals. Therefore, you can write AX is equals to AX, as things which are equals to the same thing are equal to one another. Then you write, according to the theorem 10.2, tangents from the external points are equal. Tangents from the external point are equal. Use that concept to prove this. So you write, in the given figure, you write AY is equals to AP. AY equals AP. Reason theorem 10.2. Tangents to a circle drawn from the external point are equal. Consider this is the first. Same theorem can be used to the circle with center C also. Take A is the external point. From that A, AX and AP are drawn. Then you write AX equals AP. Same theorem. Which theorem? 10.2. Consider this is second one. From first and second, from first and second. Here RHS are same, therefore LHS must be equal. AY is equals to AX. What you can write? AY is equals to AX. Question number 29. 29th question. Two concentric circles of radii 5 cm and 3 cm are drawn. Find the length of the chord of the larger circle which touches the smaller circle at P. This is the chord of the larger circle and it touches the circle, inner circle at P. So it is tangent to the inner circle. You know that OP is perpendicular to the chord. If you name it AB, OP is perpendicular to AB. These two are the right angle triangle. Radius at the point of contact is perpendicular to the tangent. By using that concept, and also one more concept, you learnt in 9th standard that the perpendicular drawn from the center to the chord bisect the chord. Here AB is bisected by the point B. Why OP is perpendicular to AB? That is according to the theorem 10.1. Why AB is bisected by OP? That is the concept that you have learnt in 9th standard. Perpendicular drawn from the center to the chord bisect the chord. You have to use these two concepts. Then you write in the figure. You write in the figure. AB is a chord of bigger circle. Chord of bigger circle. And tangent at P to the smaller circle. Then you write OP perpendicular to AB. OP perpendicular to AB. That is according to theorem 10.1. And you know that the perpendicular drawn from the vertex center to the chord bisect the chord. Then you take the triangle OPB. In the right angle triangle OPB, apply the Pythagoras theorem. Here AB is the hypotenuse and the square on the hypotenuse is equals to the sum of the squares on the other two sides. Then you will get PB. You write that OP square plus BP square is equals to OB square. OP square plus PB square equals OB square. Write that one. OP square plus PB square equals OB square. Here the radius of the circle is given, that is the radii of the bigger circle is 5 cm and the radii of the smaller circle is 3 cm. Here OB is the radius of the smaller circle and OB is the radius of the bigger circle. Then you can write OP is 3 square, that is the radius of the smaller circle. PB is to be find out, write that PB only, PB square equals OB is the radius of the bigger circle 5 square. Then you write PB square equals 5 square. 5 square is 25 minus 3 square. 3 square is 9. 25 minus 9, which is equals to PB square is equals to 25 minus 9 is equals to 16. Then PB is equals to the root of 16. PB is equals to, if square is removed in the LHS, the RHS will have the root. Then you write root 16. Root 16 is 4. You got 4 centimeter. Root 16 is 4. Then you got PB is equals to 4 centimeter. AB is equals to 2 into 4, which is equals to 8. Then you write AB is equals to 2 into 4 equals 8 centimeter. Then you write OP bisects AB. That is the concept that you have learnt in 9th standard. OP bisects AB. Question number 30. In a circle with center O, AB is the diameter and AP is the tangent. If angle OCB is equals to 25 degree, then find the measure of angle APB. Here you observe the figure. O is the center of the circle. OC and OB are the radii of the circle. And angle OCB is given. Angle OCB is equals to 25 degree. We have to find the measurement of the angle APB. How will you get the measurement of the angle? We have to take the triangle APB. In this triangle, you will get the measurement of B. Angle B is equals to 25 degree. Because OB is equals to OC and angle OBC and angle OCB are the angles opposite to the equal side. So they are equal. Then the measurement of the angle OBC is equals to OBC means OBP is equals to 25 degree. This is 25 degree. This is 90 degree. Angle ABP is 25 degree. Angle BAP is 90 degree. Then by using angle sum property, 180 minus sum of these two angle, you will get the measurement of the angle APB. So you write, first you take the triangle OBC to find the angle B. Right? In the triangle OBC, in triangle OBC, OB equals OC. Why they are equal? Radii of same circle or radii of a circle. Then angle OCB equals angle OBC, both are equals to 25 degree. Here OCB is 25 degree means OBC is also 25 degree. They are the angles opposite to equal sides. That is the concept you learned in 9th standard. In a triangle, if two sides are equal, then the angles opposite to the equal sides are equal. Then you write, what is the reason we have to write? Then you write angles opposite to equal sides. Now you take the triangle BAP. It is a right angle triangle. Angle A is equals to 90 degree. That is according to the theorem 10.1. Then you write angle A equals 90 degree. Reason? Theorem 10.1. Here A is a point of contact. OA is the radius through the point of contact. Radius through the point of contact is perpendicular to the tangent. So OA is perpendicular to AP. Then you write the name of the triangle ABP. In triangle ABP, what we have to find out? Angle P. Angle APB is to be find out. Write the name of that triangle. Angle APB is equals to what? 180 minus 90 plus 25. By using angle sum property of the triangle, you can take this 90 degree plus 25 degree equals 180 degree minus sum of these two. 90 plus 25 is 115. Then 180 minus 115 is 10 minus 5 is 5 and 7 minus 1 6. 1 minus 1 0. So I got 65 degree. Then what is the measurement of the angle APB? Angle APB is equals to 65 degree. Angle APB is equals to 65 degree. Now 3 marks question. Fourth main. Answer the following questions. 3 marks. The question number 31. Prove that the tangent at any point of a circle is perpendicular to the radius through the point of contact. It is a theorem on the circle. Theorem 10.1. Let us state and prove this theorem. The tangent at any point of a circle at any point of a circle is perpendicular to the through the point of contact. So what is the statement of the theorem 10.1, which is a theorem on the circle, first theorem on the circle. The tangent at any point of a circle is perpendicular to the radius through the point of contact. So let us draw the circle. So let us draw the figure. Here O is the center of the circle and P is a point on the circle and XY is a tangent. XY is a tangent. Let us join OP. Here O is a center, P is a point on the circle, then OP becomes the radius. Right? We are given a circle with center O. We are given circle with center O. Circle with center O. And XY is a tangent at a point P. XY is a tangent at P. xy is a tangent to the circle tangent to the circle at P. Now what we have to prove? We need to prove that what we have to prove? We need to prove that OP is perpendicular to XY. Say right. We need to prove that this OP is perpendicular to XY. What we have to prove? We have to prove that OP is perpendicular to XY. OP perpendicular to XY. You know that for a given line, you can draw any line. For example, this is a line, and from a given point outside the line, you can draw any number of line. And out of that, the line which is perpendicular is the shortest, and the shortest is the perpendicular. So here we have to prove that OP is the shortest distance of all the lines that can be drawn from O to XY. So let us draw one more line by taking the point Q other than P. So that is the extra construction needed here. So let us take here. Let us take a point Q on XY, or write take a point Q. Take a point Q other than P. Take a point Q on XY other than P. So you take a point Q on XY other than P and join O and Q. Here you observe the point Q lies outside the circle because XY is a tangent. Only one point lies on the circle, that is P, and Q naturally lies outside the circle. If Q lies on the circle, then XY becomes secant, not tangent. So you write that the point Q must lie outside the circle. The point Q must lie outside the circle. Reason? Because XY is a tangent. XY is a tangent at P. XY is a tangent at P. So P must lie on the circle, as P is the point of contact. Q must lie outside. Therefore you can say that as Q lies outside the circle, it must be greater than OP. So write, therefore OQ is longer than the radius OP. OQ is longer than radius OP. That is what we can write, OQ greater than OP. It happens for every point on the line XY except the point P. This happens for every point on the XY, every point on XY other than P or except P. Here P is a point on the circle and OP is a radius and Q is outside the circle, therefore it is greater than OP. The outside point is joined to center, so the line joining the center and the point outside the circle is always greater than the radius. So then what becomes, OP is shortest among all the lines that can be drawn from O to XY. Therefore you write, OP is shortest of all the lines or shortest of all the distance, let us think, shortest of all the distances from the point O to XY. From the point O to XY. Therefore you can say that the shortest distance becomes the perpendicular. Therefore you can say, therefore OP is perpendicular to XY, because the shortest line becomes the. Question number 32. Prove that the lengths of the tangent drawn from an external point to a circle are equal. The lengths of tangents drawn from an external point to a circle are equal. Let us read the statement. The lengths of tangents drawn from an external point to a circle are equal. Lengths of the tangents drawn from an external point to a circle are equal. This is the statement of the theorem 10.2, which is the second theorem on the circle. Now let us draw the figure to prove this theorem. Draw a circle with center O. Here O is center of the circle, and you take a point outside the circle which is called external point. Let us take P is the external point, and you can draw two tangents from the external point P to the circle. So take them. One is here and the other one is here. These two are the tangents, and the point of contacts are Q and R. Here what you have to prove? We have to prove that the tangents are equal. PQ is equals to PR. That you have to prove. So note down what are given here. We are given a circle with center O. We are given a circle with center O. Circle with center O. P is a point lying outside the circle. Here the word external point is there. So you take P is an external point. P is an external point, or P is a point lying outside the circle. PQ and PR are the tangents from P to the circle. PQ and PR are two tangents from the point P to the circle. Two tangents to the circle from P. This much is given. What we have to prove? We have to prove that PQ equals PR. We need to prove that PQ equals PR. So we need to prove that PQ equals PR. So to prove this PQ equals PR, you have to take the congruency of triangle. So we need two triangles. To have two triangles, we have to join this OP, OQ and OR. That is the extra construction needed. So let us join OP, OQ, OR. OP, OQ, OR. Here you know that OQ is perpendicular to PQ and OR is perpendicular to PR according to the previous theorem. According to the theorem 10.1, angle PQO or OQP and ORP. Angle OQP and ORP are right angles. So you write that one. Angle OQP and angle ORP are right angles. Reason, previous theorem, that is theorem 10.1. What is the statement of that theorem? Just now we proved that theorem. Tangent at any point on a circle is perpendicular to the radius through the point of contact. Here R is a point of contact and Q is a point of contact. So the radius drawn through the point of contact is perpendicular to the tangents. Therefore, here according to the theorem 10.1, OQP and OQP and ORP are right angles. Now, to take the triangle, take triangle OQP and triangle ORP and prove that they are congruent triangle. How will you prove that two triangles are congruent? That is, according to any one of the congruence rule, we have to prove that the two triangles are congruent. If you prove triangle OQP is congruent to triangle ORP, then naturally you will get PQ is equals to PR. How will you prove that these two triangles are congruent? In these two triangles, you know that already proved these two are right angles, and OP, hypotenuse OP equals hypotenuse OP, that is a common side, and OQ is equals to OR. They are the radii of same circle. Radii of same circles are always equal. Radii of same circle are always equal. Therefore, according to RHS congruence rule, you can prove that the two triangles are congruent. Right? In triangle OQP, so write in the right angle triangle only, because they are right angle triangle. In the right angle triangle, OQP and right angle triangle ORP, and radii OQ equals radii OR. So write, first you write OQ equals OR. OQ equals OR. Reason, radii of the same circle. Radii of the same circle. Right, hypotenuse OP equals hypotenuse OP. You can write, or otherwise you can leave the word hypotenuse. Directly you write OP equals OP common side. OP equals OP common. So you write common side. Therefore you can write triangle OQP is congruent to triangle ORP. According to which congruence rule? RHS congruence rule. So write RHS. Then you can say that according to CPCT, PQ is equals to PR. Right? CPCT. Corresponding parts of congruent triangles. So I got the result here, PQ equals PR. Question number 33. PQ is a chord of length 8 cm of a circle of radius 5 cm. The tangents at P and Q intersect at a point T. Find the length of TP. TP and TQ are the tangents from the external point T. So TP is equals to TQ. Therefore, triangle TPQ is an isosceles triangle in which TP is equals to TQ. PQ is a chord. PQ is a chord and TR must bisect PQ. Angle PTQ is equals to angle RTQ because it is the angle made by the line joining the center and the external point. So, the angle made by the line joining the center and the external point subtend equal angle at the center and also equal angle at the external point. So, these two angles are equal. Then, TO becomes the angular bisector of the angle PTQ. TO is the bisector of the angle TPQ. So, it must be perpendicular to the base. So, AOT is perpendicular to PRQ. By using this concept, you can consider this PRQ. With the help of that concept, you can consider triangle PRO is right angle triangle. And apply the Pythagoras theorem, find RO. One more thing you know that the point R is perpendicular to PQ and also it bisects PQ. So, these are 4 centimeter and 4 centimeter and here you take it 4 centimeter and in the right angle triangle PRO apply the Pythagoras theorem and get the measurement of this RO. Now you write, in the figure TP is equals to TQ, that is according to the theorem 10.2. Theorem 10.2. Therefore, triangle TPQ is an isosceles triangle. TO becomes the angular bisector of angle PTQ. Then you write TO is the angle bisector of angle PTQ. So, you can take TR perpendicular to PQ. TR is nothing but the part of TO. So, you write TO perpendicular to PQ. PQ is a chord and TO is perpendicular to PQ means TO must bisect PQ. Perpendicular drawn from the center to the chord, bisect the chord, then you can write TO bisects PQ. Therefore, TO bisects PQ, then you can write PR is equals to RQ is equals to 4 centimeter. Therefore, you write PR equals RQ equals 4 centimeter. Then use the Pythagoras theorem to the triangle PRO. Then you write in the right angle triangle PRO, which is the hypotenuse, PO is the hypotenuse given. What you have to find out? We have to find out RO. Then you write OR square plus PR square is equals to PO square. OR square is to be find out. Write OR square is equals to PO square minus PR square. PO square is 5 square minus 4 square. That is OR is equals to square root of 5 square is 25 minus 4 square is 16. You got OR is equals to 25 minus 16 is 9 equals 3 centimeter. Then here you got the value of OR, and if you consider these two triangles, according to the question we have to find the length of TP. To find the length of TP, we have to prove that triangle PTR is similar to triangle PRO. So write the name of the triangle TRP and triangle PRO and prove that they are similar. In a triangle, they are right angle triangle. In triangle TRP and triangle PRO. So angle PRT is equals to angle PRT plus angle ORP equals 90 degree. Both are right angles. In triangle PTR, angle PRT is equals to 90 degree and the sum of these two is 90. So angle PTR is equals to 90 minus angle TPR. Similarly, angle OPR is also equals to 90 minus angle TPR. So they are equal. Then you can write angle PTR which is equals to 90 minus angle TPR, that is equals to angle OPR. Both are equals to 90 minus angle TPR. This angle PTR is equals to 90 minus angle TPR. This angle OPR is also equals to 90 minus TPR. 90 minus TPR is PTR and OPR. So they are equal. As two angles are equal, PRT is equals to ORP, PTR is equals to OPR. You can write that triangle TRP is similar to triangle PRO. According to AA similarity criteria. AA similarity criteria. Then as we have to find out TP, write the ratio of the corresponding side. TP by PO equals RP by RO. RP by RO. Here TP is to be find out. PO is known, RP is known and RO is known. Then you can write TP by PO. PO is 5. You got here PO is 5 equals RP is 4. RO is 3. You got it? 3. Therefore, TP is equals to 4 into 5 by 3. 4 into 5 by 3 which is equals to 20 by 3 centimeter. Question number 34. Two tangents TP and TQ are drawn to a circle with center O from an external point T. Prove that angle PTQ is equals to 2 angle OPQ. Here we have to prove that angle PTQ is equals to 2 angle OPQ. How will you prove this? First you consider the triangle TPQ. In that triangle, TP is equals to TQ. So, angle TPQ is equals to angle TQP. Then you will get angle PTQ is equals to 180 minus these two angle. So, here you take this angle. Angle TPQ is equals to 180 minus angle PTQ whole divided by 2, that is this angle. Here you take angle TPQ. This angle becomes the common for this TPO. Angle TPO is 90 degree. 90 minus angle TPQ is equals to angle OPQ. Write in triangle TPQ. In triangle TPQ, TP equals TQ. According to theorem 10.2, tangents from the external point are equal. Theorem 10.2. Therefore, you can write angle TPQ equals angle TQP. Both are equals to 180 minus angle T by 2. Right? Therefore, angle TPQ, or you write TQP first. TQP equals angle TPQ. Both are equals to 180 minus angle T. Angle T means angle PTQ. 180 degree angle minus angle PTQ by 2. These two angles are equal and they are equals to 180 minus this angle T whole divided by 2. Then you can use angles opposite to equal sides and angle sum property. Angles opposite to equal sides. For these two angles are equals, what is the reason? Angles opposite to the equal sides. 180 minus angle PTQ by the angle sum property. Angle sum property. Sum of three angles of the triangle is 180 degree minus angle PTQ. That remaining angle 180 minus angle PTQ must be divided by 2 to get the measurement of these two angles. Here we have to express the relation angle PTQ equals 2 angle OPQ. You need the angle OPQ. So angle OPQ is equals to what? Angle OPT minus angle OPQ. Then you write here OPT is equals to 90 degree. You know it because according to the theorem 10.1, TP is a tangent at P and OP is the radius at the point of contact. OP is perpendicular to AB. Therefore, you write angle OPT is equals to 90 degree. That is according to the theorem 10.1. Theorem 10.1. Then you take this angle. Angle OPQ is equals to what? Angle OPQ equals angle OPT minus angle TPQ. Right? Angle OPT means which angle? 90 degree angle. You write 90 degree minus angle TPQ. Angle TPQ. Here you have taken this is first. Then you write angle OPQ equals 90 degree minus angle TPQ is equals to what? 180 minus angle PTQ by 2. 180 minus angle PTQ by 2. Write it in the bracket because two terms are there. Then write the reason from first. Then you write angle OPQ is equals to, write this 90 degree as it is, minus 180 by 2 minus angle PTQ by 2. And in the next step, angle OPQ equals, write this 90 degree minus 180 by 2 is 90 minus angle PTQ by 2. Now you open the bracket and you write angle OPQ equals 90 degree. Open the bracket. It becomes minus 90 degree and minus into minus plus angle PTQ by 2. Now you cancel this 90 degree. You got OPQ in the LHS, which is equals to angle PTQ by 2. Then you do the cross multiplication. 2 into angle OPQ is equals to angle PTQ. Therefore, you can write angle PTQ is equals to what? 2 angle OPQ. Interchange the LHS and RHS. 2 angle OPQ. Question number 35. In the given figure, PQ and RS are two parallel tangents to a circle with center O and another tangent AB with the point of contact C intersecting PQ at A and RS at B. Prove that angle AOB is equals to 90 degree. Here what we have to prove? We have to prove that angle AOB is equals to 90 degree. This is to be proved. To prove that, you know that XOY is a straight line and it is a diameter of the circle. By joining the point of contact of the parallel tangent, you will get a diameter of the circle. The line joining the point of contact of the parallel tangent passing through the center of the circle, so it becomes the diameter. Then you must know that angle XOY is a straight angle that is equals to 180 degree. A is the external point. AX and AC are the tangents from the external point and they are equal. Similarly, B is an external point. BC and BY are the tangents from the external point and they are equal. And it is according to the theorem 10.2. You proved in the theorem that tangents drawn from the external point to the circle are equal. How you proved? By taking these two triangles and proving they are congruent. Similarly, triangle AXO and triangle ACO are congruent. According to RHS congruence rule, you can prove that the two triangles are congruent, and according to CPCT, you can have these two angles are equal. Angle XOA is equals to angle COA. Similarly, you can have angle COB is equals to angle YOB. With the help of that concepts, you can prove angle AOB is equals to 90 degree. You take in the figure AX and AC. AX and AC are the tangents from the external point A. Therefore, in the right angle triangle OXA, and right angle triangle OCA, here these two are right angles. You know, the angle between the tangent and the radius at the point of contact is always equals to 90 degree. The radius at the point of contact is perpendicular to the tangent. So you can have the right angle triangle here. And here you can observe OA is the common side and OX is equals to OC, as they are the radii of the same circle. Then you write OX equals OA, or first you write the hypotenuse OA equals OA, OA equals OA, common side. And OX equals OC, radii of same circle. Therefore, triangle, right angle triangle OXA is congruent to right angle triangle OCA according to RHS congruence rule. Therefore, these two angles are equal. Angle XOA is equals to angle COA. Angle XOA is equals to angle COA, that is according to CPCT. Similarly, these two angles, angle COB is equals to angle YOB. Angle COB is equals to angle YOB. Then you take, let, here you got angle XOA is equals to angle COA, and here angle COB is equals to angle YOB. These two are equal and these two are equal. So let us take these two angles are equals to A and these two are equals to B. So you write, let angle XOA equals angle COA is equals to A. Let angle XOA equals angle COA equals what? A, and here angle COB is equals to angle YOB. Angle COB equals angle YOB equals B. Now take the sum of all these four angles. Right? A plus B plus B equals which angle? XOY, which is a straight line. Angle XOY. Then A plus A to A, B plus B to B is equals to 180 degree because XOY is a straight line. 2A plus 2B is equals to 180 degree because XOY is a straight line. Then here you remove 2 common. 2 into A plus B is equals to 180 degree. Then you transfer this 2 to the RHS. You got A plus B equals 180 degree by 2, which is equals to 90 degree. In the figure you observe A plus B is which angle? That is angle COA plus angle BOC, which is equals to what? AOB. Then you write A plus B is equals to which angle? Angle, that is angle AOB is equals to 90 degree. Here you write A plus B is equals to angle AOB.